Hello, people. Good morning. You've already done two classes on rotational motion. So, उसमें हम लोगों ने क्या पढ़ा है? We studied what is rotation. ठीक है? The kind of motion where different parts of an object are moving in different ways is called as rotational motion. उसमें axis of rotation होता है. एक ऐसा point जो कि rest पे रहता है, does not rotate. है ना? फिर उसके बाद what did we study? Mass of an object. जब object straight line में जाता है, when an object is moving in a straight line, तो उसका mass होता है. When an object is rotating, the mass of an object is represented by its moment of inertia. The moment of inertia दो चीज़ों पर depend करता है. It obviously depends upon the mass of an object. Heavy objects will have higher moment of inertia. और दूसरा चीज़, it depends upon the axis of rotation, the perpendicular distance from the axis of rotation, and we did a lot of derivations based on that. So if you guys didn't understand the derivation for the ring, for the sphere, and for the shell, the one thing we can do, one way we can do this is that we can just try to know the values instead of understanding the integration. Though I'll explain the integration for a ring once again in this class. What I would suggest is if you do not understand integration at this stage, it's not that important to know the integration thing right now. नहीं समझ में आ रहा है derivation तो छोड़ दो और directly इसका value याद रखो. The value is more important. Like when you'll be solving problems, you'll be requiring the value. So just know the values first, and then you can like do the integration whenever you're comfortable. Okay. So moment of inertia of standard objects. Moment of inertia of standard extended objects. Standard का मतलब ये है कि these are objects whose shape is like a geometrical shape. We know the shape as a standard shape. Like for example, a ring. So the moment of inertia of a ring about its center. Okay, about its center. So instead of writing center with almost every shape, what I'll do is moment of inertia of extended objects about their center of mass. About their center of mass. So for a ring, the moment of inertia is equal to mr square. How does a ring look like? A ring looks like, of course, a ring, and then the mass is m and the radius is r. ठीक है? तो अपन इसका moment of inertia लेते हैं. The moment of inertia is equal to mr square. What is the moment of inertia of a disk? How does a disk look like? Kind of like a biscuit. ठीक है? तो half mr square. Moment of inertia of a biscuit. So a biscuit is exactly like a ring. There is no difference, at least on paper, there will be no difference, except the mass is spread out all over the disk. And the moment of inertia about the center of the disk for a radius of r and a mass of m is equal to half mr square. Okay? Now, the moment of inertia of a shell. What is a shell? A shell is an empty sphere, like a plastic cricket ball or stuff like that, like a ping pong ball, table tennis ball. All of these are shells. Okay, the shell is 2 by 3 mr square. The moment of inertia of a shell is 2 by 3 mr square. ये shell का moment of inertia है. So a shell exactly looks like a sphere on paper, so it will not make any sense to draw a shell, but this is a shell. The radius is r and the mass is m, and the moment of inertia of the shell is equal to 2 by 3 mr square. ठीक है? उसके बाद sphere. So I'll not sit down and derive these values today because I realize that, like, maybe the integration thing is not that comfortable with you. Fine. Though I'll show you the idea of a ring. Try to follow the derivation of a ring once again. I want you to understand integration का मतलब क्या होता है. Even though you're unable to like set up an integration and do it on your own right now, you have 2 years ahead of you. तुम सीख जाओगे. But right now just understand integration होता क्या है. Why are we integrating? ठीक है? तो sphere का moment of inertia is 2 by 5 mr square. For a sphere, the moment of inertia is 2 by 5 mr square. A sphere and a shell, they look very similar to each other, except a sphere is going to have all throughout it. There's going to be like, there is mass all throughout the sphere. The radius of the sphere is r. The mass of the sphere is m. And the moment of inertia of the sphere is 2 by 5 mr square. So we have ring, we have disk, we have shell, we have sphere, we forgot rod. So the moment of inertia of a rod, one of the first things we did yesterday, is equal to 1 by 12 ml square. The rod is one of those shapes where two things about the rod are standard. So first of all, if you take the rod, this is the moment of inertia about the center of the rod, about this axis, about the center of the rod, where the length of the entire rod is L. and the mass of the entire rod is m. तो ये उसका moment of inertia है. There is also the moment of inertia of a rod about the edge of the rod. If you remember yesterday, that was 1 by 3 ml square. So what is this? This is the moment of inertia of the same rod. We are taking exactly the same rod as above, length L and mass m, except the moment of inertia is found out about a point that is its edge, the edge of the rod. Rod ऐसे घूम रहा है. That is the midpoint of the rod. This is the edge of the rod. ठीक है? There is also the moment of inertia of a rectangular plate, thin rectangular plate. The moment of inertia of a thin rectangular plate is equal to 1 by 12 m a square plus b square. ठीक है? So what is a and b? A and b are the width of that plate. So if you take a rectangular plate, my plate might look a little bit square to you. If you take a rectangular plate, this is a, and that edge of the plate is equal to b. This is the mass m of the plate. So if you take the center of it, like you spin a copy on your hand, ठीक है? Finger पे ऐसे copy spin करते हो, exact same situation. The moment of inertia of such a thing is equal to 1 by 12 m a square plus b square. So this is the moment of inertia of some standard extended objects. Of course, the moment of inertia can be found out for almost any object by using integration. Right now, we'll try to teach you the moment of inertia of a ring once again. I'll try to show you how to do the integration for some standard object, like for some okay, random object. If you can do it, good for you. Otherwise, there are some few basic problems at this stage that you should practice. Once you're ready, let me know about the integration and I'll show you some problems about okay, more difficult extended objects. Simple ring का derivation एक और बार करते हैं. A simple idea about the integration for a ring. Take a ring, ठीक है, simplified non mathematical derivation. एक ring लेते हैं, but this time I am not taking a ring like I showed it in the last class. I am going to take a ring as a simple point mass. This is a point mass, a very small amount of mass, and it is part of a ring. So if you join all of these masses, so you will get a big ring. So you take one mass, then you take the next mass, then you take the next mass next to it. You start drawing all of these dots together. The kind of like joining the dots in a diagram, if you join many dots, you will end up getting a ring. So out of all of these dots that make up a ring, I'm going to take one of it. The radius of the ring is equal to r. Ring का जो radius है, the radius is equal to r. I'm taking one of these dots. So let's say we are taking this dot over here. This is the dot that we are taking. ठीक? What is the moment of inertia of that dot? The moment of inertia of that single dot is equal to m r square. कौन से एक्सिस के about the center, ठीक है, about the center of the ring. The moment of inertia of that dot is equal to mr square. What is the moment of inertia of the ring? I. What is the moment of inertia of our dot? We should not write I, we should write di, because it is a part of the moment of inertia of the ring. So whenever you write d something, so it just in English it means part of I, part of I. D means differential, a very small part. So that's the understanding. If you take the moment of inertia of that dot, that is di. Di is equal to mr square. अब ये चीज देखो कि all of these masses, they are all going to be m because they're each a very small part of the ring. ठीक है? Each of these masses are a small part of the ring. If you want, you can divide the ring further into even smaller parts. So the mass of each part is going to become even less. ठीक है? Even और छोटा हो जाएगा अगर तुम ring को और छोटे छोटे parts में divide करोगे, like I am doing right now. Then the mass of each of these parts is going to become less and you're going to end up with even more number of parts. But keep in mind, the mass of each part is going to be some part of the mass of the ring. तो अगर ring का mass m है, then the small m over here is actually a part of the mass of that ring. So you can write it as dm. समझ में आया? This is what we did in the last class, and from here we did an integration. In today's class, what I want to do is I want to avoid that integration. I explained to you integration क्या होता है, and I want to avoid that integration and I want to still solve and find out. So what I'll do is I'll say that di is the moment of inertia of a single dot. So if I add up all the dots, if I add up all the moment of inertia of all the dots, all of them, then I'll get the moment of inertia of the ring. So what I have to do is I have to add up the moment of inertia of each dot, summation mr square. For all the dots, the distance from the center is the same. That's why it's a circle. So I'll end up with summation m. What will happen if I add up all the masses like here? I'll get the mass of the ring. So that is simply mr square. I hope this derivation was easier to you. It was slightly a different idea than last class. So keep in mind, this is mathematics. You can do one thing in several different ways. The key idea here is to understand actually what is going on. You're taking a very small part of the ring. You're finding out its moment of inertia. Okay, that is the first step. You take a very small part. Take a very small part. It is not always essential that you take a small part as a dot. Sometimes the small part could be a ring. Sometimes the small part could be a disk. So you can take it in different ways. I gave you kind of a deep understanding in the second lecture if you listen to it. I said that if you take a line, if you take a rod, the rod is a one-dimensional object. So the small part has to be a zero-dimensional object. It has to be a point. If you take like a ring, that is also a one-dimensional object because you can bend a rod into a ring. So a part of that ring has to be a zero-dimensional object. It has to be a dot. बट इफ यू टेक समथिंग लाइक अ डिस्क इज ए टू डायमेंशनल ऑब्जेक्ट. ठीक है, टू डायमेंशन का ऑब्जेक्ट होता है, वो उसमें फ्लैट होता है, इट हैज एरिया, यू कैन होल्ड इट इन योर हैंड्स, इट्स अ टू डायमेंशनल ऑब्जेक्ट लाइक अ पीस ऑफ पेपर. तो इफ यू टेक अ स्मॉल पार्ट ऑफ इट, अ स्मॉल पार्ट ऑफ इट कैन बी अ डॉट, बट दैट्स अ वेरी स्मॉल पार्ट ऑफ इट. ठीक है, बहुत ज्यादा छोटा हो गया. वी कैन स्टिल टेक अ स्मॉल पार्ट ऑफ इट एंड हैव सम शेप. वी कैन हैव अ रिंग. तुम अगर चाहो यू कैन टेक एन अनियन, यू कैन चॉप एन अनियन अप इनटू स्मॉल स्मॉल स्लाइसेस. ईच स्लाइस हैज रिंग्स इन इट, राइट. तो डिस्क का जो पार्ट होता है वो रिंग हो सकता है. तो अपन एक स्मॉल पार्ट जब ले रहे हैं तो यू कॉल दैट अ मास एलिमेंट. दैट मास एलिमेंट इज यूजुअली द लार्जेस्ट थिंग यू नो द मोमेंट ऑफ इनर्शिया ऑफ. जब हम लोग रिंग का सॉल्व कर रहे हैं हमें कुछ पता ही नहीं, तो हम लोग मोमेंट ऑफ इनर्शिया ऑफ अ डॉट ले रहे हैं. जब हम लोग डिस्क का सॉल्व करेंगे तो रिंग का हमें ऑलरेडी पता है कि इट इज एम आर स्क्वायर. द मोमेंट ऑफ इनर्शिया ऑफ ए रिंग इज एम आर स्क्वायर, ये हमें ऑलरेडी पता है. सो व्हाट वी कैन डू इज वी कैन टेक अ मास एलिमेंट एज ए रिंग. ठीक है, आई होप यू अंडरस्टैंड. फिर उसके बाद डी आई निकालते हैं. वी फाइंड आउट द मोमेंट ऑफ इनर्शिया ऑफ दैट स्मॉल पार्ट. हाउ डू वी डू इट? गिवन आवर नॉलेज वी फाइंड आउट द मोमेंट ऑफ इनर्शिया ऑफ अ स्मॉल पार्ट. जो भी मोमेंट ऑफ इनर्शिया होगा, इफ यू हैव टेकन अ लाइक इफ यू हैव टेकन अ पॉइंट मास, द मोमेंट ऑफ इनर्शिया इज इक्वल टू dm into r square. If you have taken something else, like if you have taken a disk, it will be equal to half r square dm. So this depends, this entirely depends upon the knowledge about that small mass element. So this value over here, it depends upon the mass element. तो जो तुम्हारा mass element है उसके basis पे ये value depend करता है. The third step is always common. You integrate di to get your answer. You integrate di within the limits of the integration. तो कल बहुत सारा चीज था एक साथ, so maybe you like you freaked out with it. So integrate di within the limits of the integration to get your answer. So what is the limit of an integration? वो concept भी मैं तुम्हें यहाँ पे समझा देता हूँ. See, if you start from here, this is your zero position. ठीक है, think of a stopwatch. This is your zero position. जैसे the time starts ticking, then you have 1 second, 2 second, 3 second, 4 second. You keep going. Then up till here is your 90 seconds, 90 degrees, not 90 seconds, 90 degrees. Somewhere over here you have 180 degrees. Somewhere over here you have 270 degrees. So when you come back over here, you can't say I'm at 0 degrees again. So the next value over here is 360 degrees. In physics, we don't talk about degrees, we talk about radians. So you can't talk about 90 degrees, you can't talk about 180, you can't talk about 270. You'll have to talk about radians. So तुम pi radian बोल सकते हो. What is pi? Pi is 180. That's pi. So an entire circle is not 360, but it's 2 pi. You know that the circumference of a circle is 2 pi r. पता है तुम्हें? So this thing is half of pi, that's pi by 2. And this thing is the other half, so that's 3 pi by 2. So what is the limit of your integration? The limit of your integration is starting from 0 and then ending at 2 pi. So yesterday when we were integrating this is exactly what we did. So we went from 0, we went with theta from 0 to 2 pi. Okay. So this is the moment of inertia of a ring. I hope you'll understand it better right now. बाकी उसके अलावा we have all the values that we need, the moment of inertia of all the extended objects. Just know their values once. Ring is mr square, disk is half mr square, shell is 2 by 3 mr square, sphere is 2 by 5 mr square. सब याद होना चाहिए क्योंकि प्रॉब्लम में you'll require all these values. You should know all of them by heart. Rod is 1 by 12 ml square, 1 by 3 ml square if it is about the edge, and there is a plate, तो plate का हो जाएगा 1 by 12 m a square plus b square. और भी moments of inertia हैं, तो we'll talk about that later. Today, let's start with doing a few simple problems. Let's show you a few simple problems based on this, और उसके बाद we'll have theorems and other things to study also. Find the moment of inertia of a uniform rod of mass 100 grams. Find the moment of inertia of a uniform rod. Uniform rod. ठीक है? Uniform rod is a standard object. If the rod's mass is not uniform, that's not a standard object. तुम half ml square नहीं लगा सकते. So find the moment of inertia of a uniform rod of mass 100 grams. Remember to always convert your mass into SI units. So 100 grams is not a valid value. You have to convert. And length 1 meter. And length equal to 1 meter. About an axis passing through the center of the rod. About an axis passing through the center of the rod. Also find out the moment of inertia about an axis passing through one edge of the rod. दोनों चीजें हैं. So what is the moment of inertia of a uniform rod? The moment of inertia of a uniform rod is 1 by 12 ml square. It is not mr square. It is 1 by 12 ml square. तो ये वैल्यू तुम्हें याद होना चाहिए. You should not write mr square. mr square is the moment of inertia of a point mass. So it is 1 by 12 ml square. तो यहाँ पे लिखो 1 by 12. मास का वैल्यू कितना हो जाएगा 100 ग्राम्स विच इज 0.1 kgs मल्टीप्लाइड बाई एल का स्क्वायर तो एल इज इक्वल टू 1 मीटर. ठीक है. Sometimes the mistake people make is they'll take a rod, all right, they'll take the center of the rod like this and then they'll decide that this is L. No, that is not L. L is the total length of the rod, the full length of the rod from here to there, that is L. So 1 by 12 ml square. That's the moment of inertia of the rod. So इस case में it's I think very simple. So you'll just get 1 by 120. Do you remember the units? Kg meter square. What is the moment of inertia about the edge of the rod? So the edge of the rod is this point. This is your edge. So if you want to find the moment of inertia about the edge, you'll write 1 by 3 ml square. This can be written as I0 because 0 is for the center if you remember yesterday. You can call this anything else. I'll call this edge because it makes sense over here. So this is equal to 1 by 3 m which is equal to 0.1 into L again 1 meter. So that is equal to 1 divided by 30 kg meter square. समझ में आया? So there is a uniform rod of mass 100 grams, length is equal to 1 meter. Find the moment of inertia about the center 1 by 12 ml square. Find the moment of inertia about the edge 1 by 3 ml square. ठीक है. Second problem इसी पेज पे करते हैं. Let's not turn the page. Let's solve the second problem on this page itself. Two identical rods. Two identical rods are joined to form a plus sign. Two identical rods are joined to form a plus sign. So we have two identical rods. Let's say this is one rod and there is another rod which is joined along with it to form a plus sign. Two identical rods are joined to form a plus sign. Find the moment of inertia of this system about the center. Find the moment of inertia of this system about the center. If the mass of each rod is m and the length of each rod is L. समझ में आया? Two identical rods are joined to form a plus sign. Find the moment of inertia of the system if the mass of the rod is m and the length of the rod is L. तो कैसे करोगे? तो one easy way of doing this is to understand that there are two rods. So let's call it moment of inertia of A and moment of inertia of B. There are not two axes. There is only one axis, the center of this thing, and there are two rods. So what is the moment of inertia of the first rod? That is 1 by 12 ml square. What is the moment of inertia of the second rod? That is also 1 by 12 ml square because both the rods are identical in everything. Their mass and length, everything is the same. So 1 by 12 ml square. So what is the moment of inertia of the combined system? Because the axis is the same, we can write I net as IA plus IB. So you can write 1 by 12 ml square for both of the rods. So 1 by 12 ml square plus 1 by 12 ml square. So you will get 1 by 6 ml square. Keep in mind that you can add the moment of inertia of any two objects provided that the axis of rotation is the same. Okay. Now let me slightly change this question, see if you can think about it. The other rod is not perpendicular. The other rod is placed at some angle like this. The other rod is placed like this at some angle. The axis is still passing through the center. I hope you can imagine this. The axis is passing through the center का मतलब क्या है? Like, these rods, they are lying in a plane. ठीक है? and the axis is perpendicular to that plane. ये ऐसे घूम रहा है. The axis is perpendicular to the plane of rotation. So this is the second rod. This is IB right now. This is IB. What is the new moment of inertia? Think about it. You can pause the video, give it a thought. So I think you tried it. Instead of continuing to watch the video in like a sequence, try to pause and think about things. Moment of inertia जो है, we did not talk about any angle over here. Did we talk about the angle between A and B? No. So moment of inertia is not going to depend upon this angle. It only depends on perpendicular distance from the center. So whether this rod is perpendicular to A or it is even parallel to A, it doesn't make any difference. The rod could be with any angle. B और A के बीच में कोई भी angle हो सकता है. Moment of inertia दोनों का add हो जाएगा क्योंकि axis same है. ठीक है? Next question. Find the moment of inertia of a ring. Find the moment of inertia of a ring of mass 200 grams and radius 50 centimeters. Find the moment of inertia of a ring of mass 200 grams and radius 50 centimeters. 50 centimeter. This is a ring. Also find the moment of inertia of this body if it was a disk. So two things are given to you. One, mass is given to you. Second, radius is given to you. The question is asking you, find the moment of inertia of the system, assuming that it was a ring. So moment of inertia of a ring is equal to mr square. What is mass? 200 grams, 0.2 kgs. What is r? 50 centimeters, 0.5 meter square. तो अब ये तुम्हें कैलकुलेट करना पड़ेगा. 5 का स्क्वायर 25, 25 2 are 50, 50 divided by 1000 आएगा. तो what is 50 divided by 1000? You'll get 50 divided by 1000. So how much is that? 50 2s are 100, so you'll get 1 divided by 20 kg meter square. अब कैलकुलेट करो, assuming that it was a disk. So if it was a disk, then you would write what? Moment of inertia of a disk would be equal to half mr square. तो अब वही सेम चीज कैलकुलेट करते, लेकिन अपना वैल्यू आता आधा. तो वी वुड राइट 1/40 kg मीटर स्क्वायर. ठीक है. सो एट दिस पॉइंट सम ऑफ यू माइट आस्क कि दोनों का मास तो सेम है, दोनों का रेडियस भी तो सेम है, अब मोमेंट ऑफ इनर्शिया ऑफ अ डिस्क आधा कैसे हो रहा है? व्हाई द मोमेंट ऑफ इनर्शिया ऑफ अ डिस्क इज हाफ? See, this will make some sense to you अगर तुम ऐसा सोचोगे कि in a ring all the masses are very far away from the axis. Take the axis. On a ring, all the masses, they are very far away from the axis, or maybe let's say that they are at a distance of r from the axis. But if the exact same thing was a disk, if this entire thing was not a ring, but if this entire thing was a disk, think about it. Some of the masses are at the center. So because of that small mass at the center, I'm sorry, if that mass was at the edge, अगर ये mass center पे नहीं होके edge पे होता, कब? Ring में, तो उसका moment of inertia उस छोटे part का mr square होता. लेकिन when you made it a disk, some of the mass came to the center, so its contribution is zero. Some of the mass is very close to the center, its contribution is less. So mass is spread all throughout the disk from the center to the edge. So some of the mass lies very close and some of the mass lies very far. So the amount of mass that was lying far is now less. You can't say half the mass is lying far. That's not the correct thing to say. But what I'm saying is, रिंग में सारा का सारा मास एज पे लाई करता है, लेकिन एक डिस्क में थोड़ा सा मास एक्सिस के पास लाई करता है. दैट इज व्हाई द मोमेंट ऑफ इनर्शिया ऑफ अ डिस्क इज स्लाइटली लेसर. In fact, if you go to this page and if you see the moment of inertia of a if you see the moment of inertia of a sphere and for a shell, so for a shell the moment of inertia is 2/3. How much is 2/3? The value of 2/3 is 0.66 approx 0.66. What is 2/5? 0.4. Why is the moment of inertia of a sphere lesser? The moment of inertia of a sphere is lesser because the sphere is a solid object. Same logic applies. Shell में क्या हो रहा है? सारा का सारा mass edge पे lie कर रहा है, far away from the axis. The moment of inertia depends on mass and it also depends on distance from the axis. So if the distance from the axis is more, ज़्यादा distance है axis से, तो moment of inertia उस case में ज़्यादा होगा, higher moment of inertia. तो shell का ज़्यादा है because all the mass is far away from the axis. But in the case of a sphere, some of the mass is lying very close to the axis. Some of the mass is lying between the axis and the edge of the sphere. So because of all that mass, अगर shell होता तो सारा का सारा mass edge पे होता, लेकिन यहाँ पे क्योंकि बीच में लाई कर रहा है, द मोमेंट ऑफ इनर्शिया इज नॉट सो मच, इट्स स्लाइटली लेसर. ठीक है, द मोमेंट ऑफ इनर्शिया ऑफ a sphere is lesser than a shell. The moment of inertia of a disk is lesser than that of a ring. So if somebody asks you, you should be able to answer these questions directly. Let's try another question. ठीक है, I showed you two questions, ring, disk, rod का भी हो गया. एक और question try करते हैं, फिर उसके बाद let's continue doing this. ठीक है, two identical rods, two identical rods of mass 1 kg each and length half meter. ठीक है, I'll write it on the same page. Two identical rods of mass 1 kg each and length half meter are joined at an angle of 60 degrees to make a V. Are joined at an angle of 60 degrees to make a V. So there is one rod like this, and there is another identical rod which is joined next to it at an angle of 60 degrees to make a V shape. You can see the V shape, right? So to make a V shape, what is the moment of inertia of the system about the edge of the rods? तुम्हें ये edge लेना है, not the other edges of the rod. You have to take this edge of the rod. So find the moment of inertia of the system about this edge of the rod. Pause and give it a try. तो मोमेंट ऑफ इनर्शिया कितना हो जाएगा? मोमेंट ऑफ इनर्शिया फॉर ईच रॉड, तो यू विल कॉल इट रॉड ए एंड यू विल कॉल इट रॉड बी. द मोमेंट ऑफ इनर्शिया ऑफ द फर्स्ट रॉड इज 1/3, not 1/12. It's 1/3 because you're finding it out about the edge. So 1/3 m into L का square. What is the moment of inertia of the second rod? Also 1/3 into 1 into 1/2 का square. What is the moment of inertia of the system? You can add the moment of inertia of both the rods and you can find out the total moment of inertia of the system like this. So 1/3 into 1 into 1/2 ka square. 1/3 into 1 into 1/2 ka square. So how much is that? 1/4 into 1/3, 1/12 into 2, 1/6 kg meter square. ठीक है, तो एक और क्वेश्चन आता है जिसमें ए एंड बी आर आल्सो जॉइंट, दैट इज अ ट्रायंगल. तो यू कांट सॉल्व दैट थिंग राइट नाउ. तो फिलहाल तुम इतना सॉल्व कर सकते हो. मैंने तुम्हें बता दिया रिंग का कैसे निकालते हैं, डिस्क का कैसे निकालते हैं, रॉड्स के कॉम्बिनेशन का कैसे निकालते हैं. द एंगल डजंट मैटर, वी डिड नॉट यूज 60 डिग्री एनीवेयर. what matters is the distance from the axis. So because the distance from the axis is the same, it doesn't matter what angle is there between both the rods. Now something new, moment of inertia of a part of an object. ठीक है, moment of inertia of a part of an object. So if you take, for example, if you take a disk, so what we are going to do is that we are going to take a sector of that disk. So this is a disk. What I'm going to do is, this didn't look nice, moment of inertia of a disk. We are going to take a sector of this disk. So we are going to take a small part of this disk. अब तुम्हें बताना है what is the moment of inertia of this part. So what is the moment of inertia of a full disk? Let's give it a heading also. The moment of inertia of part of an object. Part of an object. Not all objects. You'll just see that we are going to do standard objects here. Other objects you will require integration. So what is the moment of inertia of an entire disk? Let's start with the ring first. Let's call this a ring. ठीक है, the moment of inertia of an entire ring कितना होता है? mr square होता है. The moment of inertia of an entire ring is equal to mr square. So if you take a part of the ring, this part is going to have some moment of inertia, let's say I part, correct? So if this is going to have some moment of inertia I part, the remaining part of it is going to have moment of inertia I minus I part. So जितना हटा दोगे उतना आएगा. Keep in mind one thing, moment of inertia depends on mass and it depends upon distance from the center. What is the distance from the center? R. What is the distance from the center for the remaining part of the ring? Also equal to R. So we can say moment of inertia of our part divided by moment of inertia of the entire ring. Whatever is the same should cancel out. What is same? The radius, that should cancel out. So we should only be left with what is different, which is the mass of our part divided by the mass of the entire ring. So keep in mind this, that mass also subtends an angle theta at the center. What is the angle subtended by the entire ring? याद होगा तुम्हें 2 pi. What is the mass subtended by our part? Theta. So we can say moment of inertia of our part is equal to theta divided by 2 pi moment of inertia of our ring. ठीक है, थीटा डिवाइडेड बाई 2 पाई मोमेंट ऑफ इनर्शिया ऑफ अ रिंग। ये तुम्हें समझ में आ गया होगा. दिस इज द फर्स्ट पार्ट ऑफ व्हाट आई एम ट्राइंग टू टेल यू. So if the moment of inertia of a ring is given to you, or it is given to you in some kind of indirect way, mass or radius, कैसे भी करके the moment of inertia of a ring is given to you, and somebody is asking you what is the moment of inertia of 60 degrees of that ring. So 60 degrees 1/6 of that ring. The moment of inertia is also 1/6. That's the first thing. Now let's come to the second part of this. इसका second part ये है, what if somebody just asks you what if somebody just asks you, sorry, what is the moment of inertia of just this part of mass m and radius r? Let us say this small part. What is the small part called in maths? Arc कहते हैं ना इसको. This small part is called as an arc, but because we are talking about actual objects, we'll call the small part as a sector. ठीक है? So let us say this mass is equal to m and the radius is equal to r, and it subtends an angle theta. So where is the axis? The axis is over here. The axis is at the center. So first thing the question is basically asking you is that you imagine that this thing was a complete ring. This is not a ring, but imagine that this was a complete ring. Now you tell us what is the moment of inertia of that very small part. So if it was a ring, the moment of inertia would be for the entire ring. Mass भी अलग होता क्योंकि the mass of a small part is m. The mass of the entire ring would be something else. Maybe it would have been capital M. ठीक है? So mass of the entire ring is I ring. Now I know that the mass of a part of this ring is equal to theta divided by 2 pi into moment of inertia of the ring. I'm using the formula on the left. Now just write down the moment of inertia of the ring. Theta divided by 2 pi m r square. Correct? What does mass depend upon? Size of that thing. So you would see that mass m depends on this angle theta. The mass of the entire ring would have depended upon the angle 2 pi. So what have we taken? Moment of inertia of the ring. तो हमें actually क्या लिखना चाहिए? Instead of writing the small mass m, we should write the mass of the entire ring, which is equal to capital M. What is theta by 2 pi into capital M? So if you divide it over here, then m is equal to theta by 2 pi into capital M. So this is equal to small m r square. You might be very surprised. The moment of inertia of a ring is mr square. The moment of inertia of a part of a ring is also mr square. Moment of inertia of a ring is also mr square. Part of a ring is also mr square. I proved it to you kaise. But if you don't like the mathematics, you want a very physics proof for this, understand that the shape is the same. You're not taking a full ring, you're taking a part of the ring. So instead of having the full mass, you're having a mass of the part alone. लेकिन शेप तो सेम है. R represents the shape. शेप तो सेम है. तो जब तक शेप सेम होगा तब तक मोमेंट ऑफ इनर्शिया भी सेम होगा. तो ये चीज ध्यान रखो कि if your shape is the same, if as long as the shape is the same, the moment of inertia is not going to be different. Moment of inertia भी same होगा. जब तक तुम्हारा shape same है तब तक तुम्हारा moment of inertia भी same होगा. ठीक है? So this was one thing I wanted to show you. Part of an object, moment of inertia of a part of an object is the same as the entire object itself. Does it apply to a disk? Yes, it applies to a disk. But keep in mind what constitutes a part. तो part का मतलब क्या है पहले ये समझो. So if you take a disk, if you take an entire disk, a part of a disk is not a smaller part. A part of a disk is like a sector of this disk. तो ये समझो कि this is what means a part of the disk. You can't take a part as a part that is inside like this. So you can't take this as a part. No, that is not a part of the disk. That is, but in that case, the moment of inertia will be different. But if you take a part of a disk like this, like, this is the part of the disk that you're taking. तो यहाँ पे moment of inertia होगा 1/2 small m r square, where small m is the mass of the part. Mass of the capital, like the total disk would be capital M. The mass of your small part is small m. So the mass of a part of a disk is also the same. Disk का part is also half m r square. ठीक है? But provided that this is the axis, the center of the disk, everything should be the same. Disk का जैसे moment of inertia निकाल रहे हो, उसका axis should be the center of the disk. तो वैसे पार्ट ऑफ द डिस्क का भी ये जो एक्सिस है, द एक्सिस शुड बी दिस सेंटर, नॉट द सेंटर ऑफ द पार्ट, दिस सेंटर। उसका भी रेडियस वही सेम आर होना चाहिए। अगर सब कुछ सेम है, then moment of inertia of a part of a disk is also equal to 1 by 2 mr square. Does it apply to shell? Yes. Does it apply to sphere? Yes. Does it apply to a rod? No, it doesn't apply to a rod, because if you take a rod and you take a part of a mass of a rod, then that's not possible. ठीक है, एक्सिस सेम नहीं रह सकता है। अगर तुम एक्सिस सेम रख के पार्ट निकालोगे तो उसका मोमेंट ऑफ इनर्शिया सेम होगा, but just be safe, it's not applicable to a rod. It's otherwise applicable to almost everything else. So this is basic moment of inertia for you. I taught you all the basics of moment of inertia, including part of an object. इसके आगे there are two theorems. When we want to find out the moment of inertia of a complicated object, we need to use a few theorems. So first of all, let me show you what is a complicated object. A complicated object would be something like this. Imagine there is a rod, ठीक है, and along with this rod there is, let's say, two balls connected to the end of this rod, like a dumbbell or something, ठीक है, and you want to find out the moment of inertia of the system about the center. तो इस center के about तुम्हें इसका moment of inertia निकालना है. So this sphere is going to move forward, that sphere is going to move backward, the length of the rod is L, the radius of the sphere is R, this is small m, that is capital M, this is small m. What is the moment of inertia of this system? So you might say the moment of inertia of the rod is equal to 1 by 12 ml square. बिल्कुल सही. The moment of inertia of the sphere is equal to 2 by 5 mr square. वो भी सही. Can we add them? Yes, we can add them. So 2 by 5 mr square अपन लिख सकते हैं. Moment of inertia of this sphere is also 2 by 5 mr square. You can also add 2 by 5 mr square. बस एक छोटा सा problem है. Moment of inertia of a sphere about the center is 2 by 5 mr square. About something else, we don't know the moment of inertia. So while you can add 2 by 5 mr square, that is not the right value, because that value is about the center of the sphere. So if you take the center of the sphere, there will be two axes separately, one over here, one over there. So if the axis is different, you cannot add moment of inertia. So this is a problem जिसका तुम्हें at this moment solution नहीं पता है, तो तुम्हें नहीं पता इस चीज को अभी कैसे solve करते हैं. तो first of all, let's teach you something that's called as the parallel axis theorem. तो एक चीज होता है that is called as the parallel axis theorem. Let's just remove everything from here. ठीक है, सब हटा देते हैं यहाँ से. तो there is something that is called as parallel axis theorem. Parallel axis theorem क्या होता है? If you have an object and the moment of inertia of that object about some axis is known. Some axis matlab it should be about the center of an object. So this theorem is your parallel axis theorem. Parallel axis theorem. There are two theorems, parallel axis theorem and perpendicular axis theorem. So if you have an object जिसका moment of inertia about the center I0 is known, तुम्हें अगर I0 पता है, then the moment of inertia about any other axis that is parallel to this axis and at a distance of r, the moment of inertia about any other axis that is parallel to this axis and at a distance of r is equal to I0 plus mr square. What is a parallel axis theorem? For an object whose moment of inertia about the center of mass, keep this in mind, about the center of mass, not anything else, center of mass is known. For an object whose moment of inertia about the center of mass is known, the moment of inertia about any other axis, parallel to the center of mass axis, ठीक है, parallel to the center of mass axis at a distance of r, is given by moment of inertia about that other axis is equal to moment of inertia about the center of mass axis plus mass multiplied by r square. ये तुम्हारा होता है parallel axis theorem. That is the parallel axis theorem. the axis should be parallel to each other. So in the diagram that I gave you, see that I've removed almost everything else. All the unnecessary details are removed. See that the axes are all parallel to each other. सारे axes जो हैं, they are all parallel to each other. So what do you have to do? You have to find the distance between these axes. So this distance is equal to L by 2. That distance is also equal to L by 2. So both of these distances are equal to L by 2. So you can write the moment of inertia of the sphere is equal to 2 by 5 mr square. ये moment of inertia of the sphere है about its own axis. But the axis that we are given, the center of mass of the rod or जो भी है ये, the axis that we are given, I'm writing I star. So for that axis, the moment of inertia is how much? 2 by 5 mr square plus the mass of the sphere. Now it doesn't matter if it's a sphere or a ring or whatever. So just the mass of the sphere, m, multiplied by the distance from the central axis, which is equal to L by 2 का square. तो ये कितना हो जाएगा? 2 by 5 mr square plus ml square by 4. That is your moment of inertia of that sphere about this axis. So moment of inertia of a sphere about its own axis is equal to I0. This is that part. स्फीयर का 2/5 होता है, इसलिए मैंने बोला था सारे वैल्यूज याद होने चाहिए. ठीक है, तो मोमेंट ऑफ इनर्शिया ऑफ द स्फीयर अबाउट इट्स ओन सेंटर इज इक्वल टू 2/5 mr square. But moment of inertia of this thing about the central axis, you'll have to add ml square, मतलब डिस्टेंस फ्रॉम द एक्सिस का स्क्वायर, m into l by 2 का स्क्वायर, mr स्क्वायर. इसको तुम ऐड करोगे, दैट इज द पैरेलल एक्सिस थ्योरम. पैरेलल एक्सिस थ्योरम का एक एप्लीकेशन भी है. देयर इज एन एप्लीकेशन ऑफ दिस थ्योरम. Let us say that we know where the moment of where the center of mass of an object is. So you take some random object और हमें पता है इसका सेंटर कहाँ पर है. हमें ये नहीं पता कि इसका मोमेंट ऑफ इनर्शिया कितना है, बट वी नो वेयर द सेंटर इज. वी डोंट नो द मोमेंट ऑफ इनर्शिया अबाउट द सेंटर, but we just know what the center is. Now, if we are given some point and an axis passing through that point, let us say this axis is equal to 1. This is your 0th axis, this is the first axis. And let us say we are given a second axis, let's say somewhere over here. ठीक है, this is the second axis. और हमें निकालना है I2. I1 is given to us. We want to find out I2. How can we find out I2? One normal way that I've seen students do this, and that's a wrong way to do it, they find out the distance between the axes and they will directly write I2 is equal to I1 plus mr square. This thing obviously is a wrong thing. This is wrong. क्यों गलत है? Why is this wrong? It is wrong because I1 is not the center of mass axis. If it is not the center of mass axis, the parallel axis theorem will not apply. तो because ये center of mass axis नहीं है, तुम solve नहीं कर सकते ऐसे. क्या कर सकते हो? You can find out this distance A. Actually, this distance will be given to you. You can find out this distance B. And then you can start writing that I1 is equal to I0 plus MA square. अगर हमें I0 पता होता तो I1 is equal to I0 plus MA square. What is I2? I2 is equal to I0 plus MB square. Now you subtract both of it. So you can just directly write I2 minus I1 is equal to MB square minus MA square. तुम्हें तो I1 given था. The value of I1 was already given to you in the question. So what you can do is you can write I2 is equal to I1 already given to you. Mass of the object already given to you. Distances P and A already given to you. So you can write I2 is equal to I1 plus mb square minus a square. So this is how you find out the moment of inertia if the moment of inertia about the center is not given. The moment of inertia about the center of mass is not given. Okay. So again, it is not given. Keep in mind that this way is actually wrong. You can't directly find out the distance between the axes and find it out. You have to write an equation like this and then you have to solve it. So what is the parallel axis theorem? If the distance between the axis passing through the center of mass and the axis passing through a point is r, then the moment of inertia about that axis is equal to I0 plus mr square. What is wrong? If you take two axes, not through the center of mass, you take any two axes, and then you apply the parallel axis theorem, the theorem will be wrong. Theorem काम नहीं करेगा. Where can the parallel axis theorem be applied? It can be applied almost anywhere where there is like an object और वो जो axis है उसकी center of mass के through pass नहीं करता है. Let's give you an example. Let us say that there are three rods. एक rod है, एक और rod है, एक और rod है. There are three rods. All of the masses are m. ठीक है? And their lengths are L, and the axis is passing through the center of these rods. Try to imagine this as a 3D figure. Okay? So these rods are rotating kind of like a blade about this axis. So सबका length L है, mass M है, and the entire system is rotating. What is the moment of inertia of this system? The moment of inertia of the system कितना हो जाएगा? If you took the axis passing through the rod, if you took an axis that was passing through the rod like this, then the moment of inertia about that axis would have been equal to 1 by 12 ml square. First of all, recognize that this system has three parts to it. This is one rod, this is another rod, and then this is the third rod. So basically, whatever you get for one rod, you have to simply multiply it by 3 to get your answer. Okay? So if you call the rods A, B, and C, then the moment of inertia that we want is IA plus IB प्लस आई सी. तीनों को बस तुम्हें ऐड करना है और तुम्हें मोमेंट ऑफ इनर्शिया मिल जाएगा. और तीनों सेम ही आएगा. ए का जितना आएगा, बी का उतना आएगा, सी का उतना आएगा, सबका सेम आएगा. बस कितना आएगा पहले ये देखो. तो सेंटर ऑफ द रॉड इज हियर. Moment of inertia is equal to 1 by 12 ml square, but about the center. Now, what is this small distance over here? The height of an equilateral triangle is root 3 by 2 times the side. And that point divides that line in the ratio of 1 is to 3. I mean, if 1 is to 2, this is 1 and that's 2. So that's 1/3 if you know this. Okay? So ये कितना हो जाएगा? Root 3L divided by 6. So what is the moment of inertia about the center that is given to us? Let's not write O, you'll confuse it with 0. So what is the moment of inertia about the center? So let's say that the center of this thing is given by star. The moment of inertia about the center is equal to the moment of inertia about the center of the rod, this one, plus this distance squared, the mass into that distance, root 3L divided by 6 का square. ठीक है? तो रूट 3 बाई 2 टाइम्स द साइड होता है और फिर उसके बाद उसका तुम 1/3 लोगे, 2:1 रेशियो में डिवाइड करता है, तो इतना आना चाहिए, रूट 3L बाई 6 का स्क्वायर. तो व्हाट इज I0 इज इक्वल टू ml स्क्वायर डिवाइडेड बाई 12. व्हाट इज दिस? तो ये हो जाएगा m इंटू 3L स्क्वायर divided by 6 का square, which is equal to 36. So that's another ml square by 12. The total is ml square by 6. So this is the moment of inertia for one of the rods. So for each rod, you will get ml square divided by 6. So you will get three of these, ml square by 6, ml square by 6, ml square by 6. So what's your answer? Ml square by 2. So if you are given three rods and you're asked to find out the moment of inertia about the center of that system, the moment of inertia about the center ऐसे निकालते हैं. ठीक है? कितना आएगा? ml square divided by 2. Okay, I hope you understood it. If you didn't, you can go back, you can play this thing once again and you can see what is the moment of inertia of the system. कैसे निकालते हैं? Basically what I'm saying is you take the center. Understand that the center doesn't pass through the center of a rod. It is the center of the system, not the center of a rod. So because if it is the center of a rod, it is 1 by 12 ml square. It is displaced by some distance. So your answer is 1 by 12 ml square plus mass into that distance का square. Parallel axis theorem लगा रहे हो तो I0 plus m into root 3L by 6. I hope my maths is correct. So ml square by 12 plus ml square by 12, which is equal to ml square by 6. And there are three of these rods, so that makes it ml square divided by 2. तीन rods हैं तो ml square divided by 2 आएगा. ठीक है? Let's try another question. If you're ready for it, let's just try another question. Let us say that you're given a body which looks like this. There is a rod and there is half of a ring. Okay, there is a rod and there is half of a ring. ठीक है, तो रॉड का लेंथ कितना होगा? 2r हो जाएगा. रिंग का रेडियस कितना है? r है. तो द रेडियस ऑफ द रिंग इज इक्वल टू r. Automatically that gives you the mass of the rod, the length of the rod as well, and that is the ring. If the mass of the rod is small m and the mass of the ring is capital M, first of all decide, do you need to apply the parallel axis theorem? Is the parallel axis theorem required? Is PAT required? क्या लगता है तुम्हें? इज इट रिक्वायर्ड और इज इट नॉट रिक्वायर्ड? और फिर उसके बाद व्हाट इज द मोमेंट ऑफ इनर्शिया ऑफ द सिस्टम? व्हाट इज द मोमेंट ऑफ इनर्शिया ऑफ द सिस्टम अबाउट दिस पॉइंट? फाइंड द मोमेंट ऑफ इनर्शिया अबाउट द सेंटर ऑफ दैट थिंग। ठीक है, तो मैंने दिखा दिया है तुम्हें, दिस इज द सेंटर। फाइंड आउट द मोमेंट ऑफ इनर्शिया अबाउट दिस पॉइंट। तुम्हें क्या लगता है, इज द पैरेलल एक्सिस थ्योरम रिक्वायर्ड और इज इट नॉट रिक्वायर्ड? Because it's a video, you can pause it for as long as you want and think about it. What I think is the parallel axis theorem is not required. Why? The parallel axis theorem is not required because अगर तुम इसको complete करोगे, how are you going to solve it? You are going to say that the moment of inertia of my system, the answer that I require, I star, is equal to the moment of inertia of the rod about that axis plus the moment of inertia of my ring about that axis. It's not a ring, it's half of a ring. So it's that. Keep in mind what I told you. If you have half of a ring, then the moment of inertia of that ring about this point is still the same. Just इसका तुम्हें मास लेना है, पूरे रिंग का मास नहीं लेना है, इसका मास लेना और mr square लिखना है. So over here, you can write moment of inertia of the rod is equal to 1 by 12 m into L ka square. L is equal to 2r. This is the radius r. So the length of the rod, the total length of the rod is equal to 2r. So 1 by 12 ml square plus ring ka kitna likhoge? Mr square likhoge directly. You will not write anything else simply because for this axis, you already know the value which is equal to mr square. हाँ, तुम्हें वैल्यू नहीं पता होता, तुम्हें सेंटर ऑफ मास के अबाउट पता होता, इसका निकालना पड़ता, तब पैरेलल एक्सिस थ्योरम लगाते हैं. लेकिन तुम्हें डायरेक्टली इसका पता है मोमेंट ऑफ इनर्शिया अबाउट अ पार्ट, तो यू कैन जस्ट राइट m into 4r square, so that is mr square divided by 3 plus m into capital R square. So our answer is equal to m plus m divided by 3 r square. So is the parallel axis theorem required? Parallel axis theorem is not required. Why is it not required? Because we already know the moment of inertia about that axis. Whether or not it is the center of mass doesn't matter. हमें तो पता है ना moment of inertia कितना है, काम खत्म. ठीक है, तो थोड़ा बहुत बी क्लियर, पैरेलल एक्सिस थ्योरम क्या करता है, क्या नहीं करता है, कब लगाते हैं पैरेलल एक्सिस थ्योरम, कब नहीं लगाते हैं पैरेलल एक्सिस थ्योरम. Be clear about all of these things and then continue solving. I think we have spent a lot of time talking to each other over here. So let's meet again in the next class. Goodbye.